Thank you.
Hello, good evening, and a very happy Independence Day to all. So, Independence Day means freedom. So, freedom means freedom of expression and freedom of knowledge. So, let me welcome myself Rajat Mishra, the Chief Trainer of Skyy Institute. So, Skyy Institute is basically a skill training institute, and we impart skills on different sectors of engineering, digital marketing, and different other sectors. There are 100 plus courses in our catalog that we impart with the skill empowerment schools. Okay. So today's topic, it is concept of ECU system. Okay. ECU, electronic control unit. See, the vehicles before and the vehicles now have a very much uncommon things in between them. Today, the BS6 vehicles which are made are totally electronic, and the BS4 vehicles or the BS3 vehicles which are there were totally mechanical and electric. So, this transition into the electronic phase is something new for us also, and also for the technicians, operators, and the engineers, those who are working on it. So, in today's session, we will learn about how these ECU system concepts are being made, how the engineers thought of making the ECUs, and what is the process of making the ECU system. So stay tuned with me till the end of the session if you want to learn about the different parts of the ECU system. The ECU means electronic control unit. The heart of combustion engine will always be metal, but brain has long been made of sensors and actuators. See, the heart of the combustion engine is your metal, means the engine is made of metal. But the brain behind its working, the actual brain behind its working is the sensors and actuators. What do I say? Without the sensors and actuators, your vehicle cannot run. Not from today, it is from the day the motorcycle was being made. Without the sensors and the actuator system, the vehicle cannot function. And that only we are going to read today, the concept of the ECU system. So welcome you. I welcome you to the session of concept of ECU system. So let's move. So what is ECU? This term, electronic control unit, what does it mean? An engine control unit, also commonly called an engine control module, is a type of electronic control unit that controls a series of actuators on an internal combustion engine to ensure optimal engine performance. That means this ECU is a module, or we can say it is a control unit, which controls all the different sensors and actuators. Now, let me give you a brief about what is sensors and actuators. Like in our body, there are 5 sense organs. What are they? Tongue, skin, eyes, ears, and nose. Similarly, there are different sensing organs or different sensing objects in a motorcycle system. So this sensor detect and give different data to the control system, that is the ECU. And the actuators are those which really work. Like in our human body, the actuators are hands and legs. Similarly, there are different actuators in a human body which actually work. So how does the ECU do it? It does this by reading values from a multitude of sensors within the engine bay, interpreting the data using multi-dimensional performance map called lookup tables, and adjusting the engine actuator. See, the ECU system and the automobile system work similar like our human body. In our human body, we have a brain which controls the different sensors, and according to this sense organs, it makes the hands and legs work. Similarly, what happens? This ECU system, it reads the value of all the component or the sensors that it is giving. The values which are getting from the ECU or from the sense organ, they are computed inside this control unit. How they are computed? There is some lookup tables stored in the ECU system, and according to that lookup tables, the data is compared. So when this data is getting compared, according to the decision made by the ECU, the actuators perform the real work. Okay, so it is a combination of all. The sensor sends the data, the ECU processes the data, and the actuator really moves. So without this three units, this ECU system cannot function. Now let us see the theories which are used to make ECU. So behind the ECU making, the engineers, those who have developed the ECU system, they have used some theories so that to develop the ECU system. First of all, the fuel theory. Air and fuel get burned to give the byproduct CO2 and H2, that is carbon dioxide and water, that we all know. Many harmful gases like CO, NO are also produced. Many harmful gases like carbon oxides and nitrogen oxides are produced, that we also know. 14.7:1 is the optimum ratio of air to fuel for better fuel economy. Now what is this? This is called stoichiometric ratio. 14.7:1 is the ratio of air to fuel where the output or the combustion exhaust is pollution. Okay, so 14.7 part of air combines with 1 part of fuel to give the perfect combustion. Okay, so this ratio is called the stoichiometric ratio. If air value decreases, the mixture becomes rich. That means if air value is less, that means petrol is more, so it is a rich mixture. Okay, so if air value is less and the petrol value is more, it is called a rich mixture. If air value increases, the mixture becomes lean. If the air value increases, that means more air, less petrol, then the mixture becomes lean. So there are two types of mixture which are supplied to the engine. One is called as rich mixture, where the petrol value is more, and the second one is called as lean mixture, where the air value is more. Okay. So this, according to this, the fuel theory has been established. Okay. So 14.7:1 is the stoichiometric ratio. This ratio is the engineers try to achieve this ratio during the idle condition of the pipe. Now, what is the idle condition? Idle condition is something where the pipe is on starting state, but the accelerator is zero. Okay. Now, spark plug. Position of connecting rod when piston is at power stroke. See, till date we have learned that the power stroke happens or the combustion happens when the piston is at TDC, that is top dead center. So if piston is at TDC, means it is at top. Okay, so let's assume this is the piston. Okay, my finger is the piston. Okay, so this is at TDC. Okay, now this connecting rod, the connecting rod which is connecting to the piston, it is straight. Okay, so when the piston is at TDC, this connecting rod will be straight. So if at this point of time we apply all the pressure in it, what will happen? This connecting rod will bear all the pressure. So it may happen that the connecting rod can break. So the combustion or the perfect combustion never happens at TDC. Either it happens 5 degrees before TDC or it happens 5 degrees after TDC. Okay, like as if this is the connecting rod, if it will be like this, so we can give the maximum thrust to it. If it will be straight, the force will be on this one. But what we want maximum thrust. So this is placed like this. Okay, so how this is possible? If the piston is 5 degrees after TDC or 5 degrees before TDC. So 5 degrees before TDC we can't do because the engine will rotate in reverse. So we have to do the perfect combustion 5 degrees after TDC. So one concept that you have learned till now was wrong. The combustion or the perfect combustion never happens at TDC. It happens 5 degrees after TDC. So as to get the maximum thrust out of the combustion. Okay. So the total crank angle. See, it is a 4-stroke engine. To complete all the processes, it requires 2 rotations of the crankshaft. So for 2 rotations of the crankshaft, what happens? 1 rotation 360 degree, 2 rotation 720 degree. Okay. so total rotating angle is 720 degree. Okay, so spark theory says that the spark plug should spark or the maximum combustion should occur 5 degree after TDC. The spark plug should not spark or the combustion should not occur at TDC. Okay, so that is what the spark theory says. Now let's find the degree of rotation in 1 millisecond. Okay, so the crankshaft is rotating. It is taking some time for rotation. So let us find out in 1 millisecond how much this crankshaft rotates. So let us assume the RPM of the vehicle, the revolution per minute of the vehicle is 3000 RPM. Okay, so the RPM of the vehicle is 3000 RPM. So 3000 revolution in 1 minute. So this crankshaft is making 3000 revolution in 1 minute, which can be equated to 18,000 degree in 1 second. So in 1 second, it is rotating 18,000 degree. So in 1 millisecond, it is rotating 18 degree. So in each millisecond, the crankshaft is rotating 18 degree. That is only for 3000 RPM. When the RPM of the vehicle is 3000, that time the crankshaft is rotating 18 degree at every millisecond. Okay. So let's assume the spark plug is at the center of the cylinder. So let us assume the spark plug that we are using in our engine is at the center of the engine. Okay. So this is the spark plug, let's say, and this is at the center of the engine. So the time taken for the spark, okay, so spark is not an instantaneous process. Spark also takes some time. It is not an instantaneous process. So the cylinder dia is 75 mm. Okay, let the cylinder dia be 75 mm. So when the cylinder dia is 75 mm and the spark plug is at the center, so this spark will take some time to go to the end of the cylinder. So let cylinder dia is 75 mm. Speed of spark is universal, that is 2230 centimeter per second. That is the universal speed of spark. So if we calculate the time taken by the spark to reach the wall of the cylinder, it comes as 1.68 milliseconds. So if the cylinder dia is 75 mm and the speed of spark is 2230 centimeter per second, then it takes 1.68 millisecond to reach the end of the cylinder. Okay? Now, what we can conclude from the data or from the knowledge that we have got till now. So by this theory, we come to the conclusion that the time taken by the spark to reach the cylinder is 1.68 millisecond. So the spark is taking 1.68 millisecond to reach the end of the cylinder. So in 1 millisecond, the crank is traveling 18 degree. Okay, so we have found out in the before slide that in 1 millisecond, this crankshaft is revolving 18 degree. So in 1.68 millisecond, the crank travels 30.24 degree. Okay, so in 1.68 millisecond, the crank travels 30.24 degree. Okay, so what we can conclude? So hence we can conclude the firing should occur 30 degree before the optimum position of the fire. That means if the maximum power has to be achieved as 5 degree after TDC, the spark plug should spark 25 degree before TDC, so that a 30 degree gap can be maintained. Okay, so if we want to get the maximum efficiency of the power at 5 degree after TDC, the spark plug should spark is 25 degree before TDC. Okay, so this is the calculation, this is the logic that was used to take out the time of ignition of spark. So this is for 3000 RPM. For 3100 RPM it is different. For 4000 RPM it is different. So for every moment of time, the ECU is working on it, and according to the RPM of your vehicle, the ECU calculate what should be the time of spark, whether should be it 25 degree before TDC or 20 degree before TDC or 30 degree before TDC. So according to the time of spark, the ECU decides the time of spark. Okay, so this is how the ECU works. ECU takes the sensor data. So in case of this, it takes the data of your crank position sensor. So there is one sensor which records the rotation of your crank, that is called as crank position sensor. So according to the crank position sensor, it senses the degree of rotation of crankshaft, and according to it, it sparks the spark. Okay. Now here you can see there are three types of cylinder. Okay. One is called short stroke over square cylinder. Other one is a square cylinder. Third one is a long stroke under square cylinder. Now all the volumes are same. The volume of each of the cylinder is same. Now, how this cylinder behaves differently? Let us talk. So first, let us talk about the short stroke over square cylinder. So this short stroke over square cylinder is basically here. This distance is less. The stroke is the distance between. If this is the cylinder height, this is TDC and this is BDC, then this distance is called the stroke. Okay. So in case of short stroke over square, the distance is lesser and the diameter is more. The bore is wider than the stroke. So what happens? This type of cylinder can produce maximum RPM because the time taken for the connecting rod to move up and down is less. So this type of cylinder can produce maximum RPM. Okay, and you will see the crankshaft size on below. If I will show you, here you can see this crankshaft size. This crankshaft size is the smaller. So as it is the smaller, the torque is minimum. Okay, so in case of short stroke over square cylinder, torque is minimum, but RPM achieved is more. Like for example, if I will give you bikes like Yamaha RX 100, so it was a vehicle with very great acceleration but less torque. So it has a short stroke over square cylinder. So it can amplify speed, but it cannot amplify torque. Next is square cylinder. The square cylinder is same. The stroke and the bore both are same. So what happens in case of this? It behaves same. Neither the RPM is more nor the torque is. It is the medium based. Now the third type of cylinder is long stroke under square cylinder. The stroke is longer, but the bore is shorter. So what happens in this kind of cylinder? As the stroke is bigger, you will see the crankshaft size is also bigger. So in this kind of cylinder, the torque is more, but the RPM is less. Like for example, if you will see bullets, bullet has more torque in it, but the RPM is less. Okay, so in case of your three types of cylinder, the different cylinder behaves differently and they are used for different kind of engines. The short stroke over square are mainly used for engines which need more acceleration, and long stroke under square are mainly used for engines which need more low end torque. Okay. Now, there is a process which happens inside the engine which is called as scavenging. Now, what is this scavenging? In automotive uses, scavenging is the process of pushing exhausted gas charge out of the cylinder and drawing in a pressed dot of air or fuel mixture of the next cycle. This process is essential in having a smooth running internal combustion engine. Now, what happens? Like I will give you an example. What happens? When we start motorcycle, sometimes what happens, we feel a back kick. Okay, so when we start motorcycle by kick, sometimes we feel a back kick. So why does this back kick happen? Because there is air stored inside the cylinder. Okay, and that air is in pressure. So the pressure that you are applying on the kick, if that is not more than the pressure inside, then your vehicle will take back. So we can conclude that air is stored inside. So scavenging is a process by which this exhaust gas is eliminated. See what happens, let's say my vehicle is moving at 5000 rpm. If my vehicle is moving at 5000 rpm, so minimum 2000 times your intake valve and exhaust valve are opening and closing. So just imagine in a minute 2000 times they are opening and closing. So what could be the amount of time they are getting to intake the air or to exhaust the air? Very less than they are getting. Okay, so that's why what happens, the exhaust gas which is there, it cannot be properly taken up. So the process of scavenging is used. In scavenging, what happens? Intake valve opens before the closing of your exhaust. Okay, so the exhaust valve is not closed, but then also this intake valve opens. So what happens? The fresh air comes from the intake valve and it pushes the exhaust gas outside. So this process of fresh gas coming and pushing the exhaust gas outside is called as scavenging. This scavenging process affects the volumetric efficiency of your vehicle. If the scavenging of a vehicle or an automobile is good, the volumetric efficiency of that vehicle will also be good. Okay. Now, valve timing. This is very necessary. Till now, I think you must have known that the intake valve open at TDC, it closes at BDC. The exhaust valve open at BDC is closed at TDC, but that is wrong. This concept that you are getting is totally wrong. That is a theoretical valve timing diagram. But today we are going to see the actual valve timing diagram. What is the actual valve timing diagram? So in the screen you can see this is the valve timing diagram. So you will observe the exhaust valve closes 20 degree after TDC and the intake valve opens 10 degree before TDC. So this is opening and closing like that due to your scavenging process. See, I told you intake valves open before, so it is opening 10 degree before your TDC. So as to help the scavenging process. And the exhaust valve is closing 20 degree after TDC. Okay. So in this between 30 degrees, both the valves are open. The exhaust valve is also open and the intake valve is also open. So that point of time we call as valve overlap. Okay, so at the point of time where both the valves are open, that is intake valve as well as the exhaust valve, that point is called as valve overlap. Okay, so in valve overlapping, what happens? Both the valves are open. Your intake valve is also open and your exhaust valve is also open. So intake valve intakes the pressure which pushes back the exhaust through the exhaust valve. Okay, so this is how your actual valve timing diagram looks. So if you see this exhaust valve opens, it opens 45 degrees before TDC and your intake valve closes 55 degrees after TDC. Okay, so theoretically we have learning something, but inside the engine the actual process is very different. Okay, so we have to count some losses. The theoretical valve timing diagram doesn't count any losses, but in the actual engine there are certain losses which occur. So that's why the practical valve timing diagram has been provided, which does the job of scavenging the air and increasing the volumetric efficiency of your engines. Now let's see the fuel injection system. Now this is one of the most important system for a ECU unit. Okay, The fuel injection system today, all the PS6 vehicles, that is the Bharat Stage 6 vehicle, use the fuel injection setup. Okay, so it is compulsory for all the vehicles to have the fuel injection setup. So there are approximately 8 sensors and 4 actuators which are used in this setup. So maximum of the sensors are there in the engine, and they in this ECU, that is the electronic control unit, it functions. This ECU, that is the electronic control unit, it functions by taking the data of the sensors and giving it to the actuators. Okay, so let us see what are the sensors which are used in your engine. The first sensor is called oil temperature sensor. This oil temperature sensor, it detects the temperature of your engine oil, which says the temperature of engine. So by knowing the oil temperature sensor reading, the ECU knows what is the engine temperature. Next is crank position sensor. So as I told you before, this crank position sensor gives the reading of rotation of your crankshaft. So by the help of this sensor, the ECU knows the revolution degree of your crankshaft. Then we have the intake temperature sensor and intake air pressure sensor. See, fuel injector setup means no carburetor. So the air is entering, and according to that, the fuel is injected. But how the ECU will know that how much air has entered and how much fuel to be put? So these two sensors helps in the process. The intake air temperature sensor and the intake air pressure sensor, they measure the temperature and pressure of the intake air. So when we know the pressure and the temperature, so the ECU can easily calculate the volume of air that is entering. So once the ECU knows the temperature and pressure, it can easily calculate the volume of the air that is entering. So according to the volume of the air that is entering, the ECU injects the fuel from the fuel injector. Okay, so by taking the reading from the temperature sensor and the pressure sensor, it reads the volume of the air, and according to that, it sends the quantity of the fuel. Then the next sensor we have is throttle position sensor. As the name only says, throttle position, accelerator position. So this sensor tells you whether the accelerator is 0, whether the vehicle is in slow speed, medium speed, or high speed. So according to the speed of the vehicle or the throttle position sensor details, the ECU detects what is the condition of the riding of your vehicle, whether the vehicle is in idling condition, whether the vehicle is in slow speed condition, medium speed condition, or high speed condition. And according to that condition, it makes changes in the ignition timing and the fuel injection. Then we have the O2 sensor. O2 stands for oxygen. Now this O2 sensor you will find mostly in the exhaust of your vehicle, near the exhaust manifold. Now this O2 sensor detects the oxygen level in the exhaust. So what is happening by detecting oxygen in the exhaust? If there is oxygen in the exhaust, that means improper combustion is taking place. That means the time of ignition has to be adjusted. Okay, so according to the readings of the O2 sensor or the oxygen sensor, the ECU calibrates the timing of ignition. Okay, then we have the lean angle sensor. So this lean angle sensor, see what happens sometimes, it may have happened to you also. If you have fallen from a vehicle, your engine doesn't stop. Now imagine your leg is stuck in the engine and the vehicle is moving forward. That is a very dangerous scene to imagine also. So for that safety, a lean angle sensor is equipped in a vehicle. So in a lean angle sensor, what happens? When your vehicle, like this is the vehicle, when it tilts to a certain degree, the engine automatically gets off. So after a leaning of certain degree, the engine gets off automatically. So that is your lean angle sensor. Then we have the speed sensor. Speed sensor tells you what is the speed of the vehicle which is attached near the tire. So these are the 8 kind of sensors which give the different values of the engine to the ECU system, that is the electronic control unit. And by taking all the data from the sensor, the ECU calibrates it, thinks about it, and compares the data with the lookup table that is stored inside this. And according to that data which is it is getting, it processes the output and tells the actuators to work. Now there are 4 actuators in a bit. What are they? First is fast idle device. Now this fast idle device, the name is complicated, but the working is very easy. Choke. Okay, we use choke in cold starting condition of our vehicle when the engine is cold. So this fast idle device is the alternative of choke. It automatically detects the engine temperature, and if the engine is cold, it enters more amount of fuel. So it is a replacement of choke in a F5 system. Then we have fuel injector. So this injector injects the right quantity of the fuel which is advised by the ECU system. Then we have the fuel pump. See, in a fuel injector setup, the fuel which is injected through the injector has to be done in a pressurized manner. So that means we need a pump which will pressurize the fuel. So this fuel pump pressurizes the fuel inside the injector. And at the last actuator that we have is the ignition point. Now, what is this voltage of spark? 12,000 volt minimum. Minimum 12,000 volt. So minimum voltage of the spark plug is 12,000 volts. So from where this 12,000 volt is coming? The battery is of 12.8 volt only. Na? So from where this 12,000 volt is coming? This ignition coil is a step up transformer. So this step up transformer, what it does, it increases the voltage from 12.8 volt to 12,000. This 12,000 volt is done for a higher potential difference. Okay, so the ignition coil increases the voltage from 12.8 volt to 12,000. Okay, so this was the sensors and actuators that I used in a FI engine. The sensor gives the data to the ECU. The ECU works according to the sensor's data and it instructs these actuators to perform. So these are the only 4 things which actually do the work. Okay, the sensors only are the messengers, but these actuators actually perform. So this was about the different sensors and actuators which are used in a FI system. Now we will know a bit about carburetor system, the carburetor setup which was used primitively. Functions of carburetor. The first function of a carburetor is atomization of fuel. We go to a barber shop, the barber uses a sprayer. So what does the sprayer do? There is water inside the sprayer bucket and that water is sprinkled. So the sprayer is breaking the larger molecules of water to smaller molecules. Similarly, the carburetor's first function is atomization of fuel, to break the larger particles of fuel to smaller particles. That is the first work of your carburetor system. The second work of the carburetor system is delivery of required quantity of air fuel according to the system condition or operating condition. That means at idle condition, we obviously need less petrol. At high speed condition, obviously we need more petrol. So according to the condition of the vehicle, the ECU decides or the carburetor decides how much petrol to be injected. Okay, so there are 2 functions of the carburetor. One is to atomize the fuel. Second is delivery of required quantity according to the operating condition. Now, principle of working of a carburetor. See, carburetor is basically a venturi. Okay, so what is a venturi? Venturi is the component whose outer cross section is having a larger diameter and the center cross section is having a smaller diameter. So what is happening here, due to the outer cross section having a larger diameter, that is the A portion, it is experiencing low velocity and high pressure. Okay, so this A portion is experiencing low velocity and high pressure, and the B portion is experiencing high velocity and low pressure. That means there is a pressure drop created at the center of your venture. Okay, so there is a pressure drop created. So this point is connected by a connection to the petrol chamber. Now this petrol chamber is in atmospheric pressure. So the petrol chamber is in atmospheric pressure, but the point of B is in low pressure. So what happens? The petrol rises from the petrol chamber to the venture and is delivered to the engine. Okay, so this is how the petrol moves up. This petrol which is stored downstairs, it is in atmospheric pressure, whereas the air passing at center, they create a low pressure. So low pressure zone is created here, it is in atmospheric pressure. The fuel rises from here and get combined with the air which is in low pressure zone. Okay, so this is how your carburetor system actually functions. Due to the pressure difference created between the fuel storage unit and the Venturi unit, the carburetor system functions. Butterfly slide type carburetor. So this is the most advanced type of carburetor that is used. Okay, so if you see here what is happening, this is the throttle cable which is connected to a butterfly slide. Okay, so this is the throttle cable. Now, when we are rotating the accelerator, this valve which is connected to this throttle cable is open. So once that valve is opening, air started entering. So at the center, there is a low depression point or low pressure point is formed. So due to this low pressure point which is formed at the center, what happens? The piston rises up. Okay, so due to this low pressure point which is created, the piston rises up. In the before kind of carburetor which I use, what happens? This accelerator cable is directly connected to the piston. But in case of this, what happens? There is no connection, direct connection with the piston from the accelerator cable. The accelerator cable is connecting to this butterfly slide, and the butterfly slide is rotating. And according to the pressure difference that is created inside this section, the piston rises. Now here you will see carefully and minutely how the system works. You will observe this is a butterfly slide which is opening, and when the butterfly slide is opening, the air is entering through the system. So the purple portion that you will see, it is experiencing low pressure. So there are two parts. You will see upper chamber, lower chamber. So this upper chamber is in direct connection with this point due to this hole in the piston. So if the Venturi is experiencing low pressure, that means the upper chamber will also experience low pressure. And the second is the lower chamber. This lower chamber is in atmospheric pressure. You can see there are blue lines there. This blue line indicates this is in atmospheric pressure. So the lower chamber is in atmospheric pressure and the upper chamber is in low pressure. So what will happen? The piston will rise up. So due to this difference in pressure, the carburetor system works. The carburetor system main phenomena and working principle is the difference in pressure between the system. Okay, so the upper chamber which is there, it is in low pressure and the lower chamber is in atmospheric pressure. And due to this pressure difference, the piston rises up. So that was about the working of the ECU, the concept behind the ECU, working of the carburetor system, and what are the different sensors and actuators that are used in your system. Okay, see, ECU system is one of the most critical and most important part of your vehicle, because now the vehicles which are going to come and now the vehicles which are in use are fully electronic. The technicians won't be able to handle that. We need experienced, skilled engineers to handle the vehicles. So the servicing sector, the maintenance sector of the different automobile sector is going through a vast change. And this change will change our perception about the mechanics or engineers. Today's mechanic will be experienced engineers. Okay, so what we should do? We should be skilled enough to handle the things. In our regular engineering studies, we don't learn about what is the ECU. We don't learn about what are the different sensors, actuators, and how they work. But in the courses of the Skyrider, in the courses, skill design courses of the Skyrider, you will learn about the minute details that is industry oriented. So this part that I talked to you about the issue section is a just you can say it was just a brief about the system. There are different things that you should know. There are different technologies which should be equipped with. For example, carburetor system is the outdated technology. But why I am telling it to you? Because if you want to learn about the FI system, if you want to master the FI system, there is one thing you should know first, how the carburetor system works. Because if you don't know how a carburetor system works, you cannot make a issue or you cannot perfect it. Okay, so these are the concepts which are used behind working of different components and working of ECU system. Okay, so if you want to gain more knowledge or more insight on this, please join our courses. Thank you, everyone.